Today we will speak about integrating LLMs and classical machine learning and data analytics. And before that, just a few words about me. I'm CTO and co-founder of small Tel Aviv-based web intelligence company. And I'm also co-founder of a QA school for QA specialists that we run on top of this company. And previously I worked in a variety of data-related positions in Intel, Playtika, Ernst & Young. So what is our plan for the next 25 minutes? We will try to brainstorm together how we can integrate between LLM and machine learning together, where it can be more useful, where it can be less useful. We'll see very quickly, a few examples from the very recent studies of different approaches and things and cases actually when LLMs still need some help. We will go through the design patterns as we see them in our company and through use cases of how we implemented those approaches in our company. So let's start. First, of course, with the help of Perplexity, I found a really interesting study of the happiness level of the people. They try to predict the level of happiness based on the diary entries, a lot of questionnaires, but still a lot of textual data. So what we're expecting is actually that LLM will perform the best, not a lot of textual data, but still textual data for 300 people, 400 people. Even in context window we can enter this, everything will be okay, and actually LLM gave us a rather okay score, but they didn't stop there. They tried to extract features from the text, put those features into SQL database and run classical machine learning, and guess what? Machine learning wins. Another example of when LLM needs a little bit of help or still not that great is when we have very large prompts. I think when I have a lot of data and I know that I need this data, that's kind of data that I were explaining to a person to make him make a right and a full decision for me. So I try to give the same to my model, to explain everything together, and in the end, when I give a really small, short prompt, I get a better results. Strange and a little bit warning for me, because I know that this is important data, so there is kind of hallucination maybe under that. And the last example is, where should I click? Is when we have a small learning set. Here is also where machine learning models like random forest still wins. Only 80 examples of data, labeled data, gave super high F1 score with random forest, so there is still a lot of place for machine learning here. We all know that. And just a very nice thing that while building this presentation, I found out a comprehensive workbook of everything can go wrong with LLM. So if you have someone in your company who really pushing for LLM project, but you think that it's not a good stuff, just send him this research, thank me later, like everything in every domain what's going on with the LLM, here is the research. So let's go deeply into design patterns. And first is data processing. This is one we actually use a lot. And what I mean when I say data processing, I mean synthetic data generation, for example. Let's say 10 years ago, how we were dealing with imbalanced cases, oversampling or undersampling. But today, we can help, with the help of LLM, generate records that really look like real data. So it gives us a lot of space to do much, much better machine learning. Second thing is feature extraction, what we just talked about, that I have a lot of plain text. Let's extract features, build a SQL database, run on that ML. And the last one is understanding the data, to validate the data before we run the machine learning, to understand if my data is actually not a garbage, because garbage in, garbage out. I want to understand if my data is ready to run machine learning. And before we will go deeply into our use cases, just a few words about what we're doing. As I said, we're a web intelligence company, so we collect a lot of data from the web. We try to mix it together with internal database of the client, for example, SQL database, most of the time kind of a CRM data, and build on them predictions. We started as a platform for political campaign management, and after that grown into brand management campaigns. So we work with a lot of SQL, Python, and machine learning as a basis. And of course, now, as everyone, we also have LLM-based chat that's called after this nice creature called Pila. And it's super accidentally because Pila, we called it political intelligence data agent, but it's also my dog, super accidentally, of course. And I will actually start from the very interesting example that is not really specific for our domain. Because we're a self-financed company, sometimes my CEO comes to me and say, look, we're extracting data from the free text. Let's do something not really related to our domain. For example, to build AI system for Misrad Shiduchim, a matchmaking company, agency. So, what they actually had is a CRM, custom CRM system with a lot of data of religious boys and girls. And they have a lot of calls that they have a lot of data inside them and a lot of data of the mind of Shatchanim. So, we needed first of all to transcribe all those calls to make it into the text, and it was the first challenge because most of the calls were in Yiddish, and maybe it's first time in the history that 102-year-old grandpa did a QA for Yiddish. This is the whole cycle. We'll go briefly through each of the boxes. So first, we ran transcribe with a set of prompts. What prompts we used? First of all, agree with me when Shatchan is calling, matchmaker is calling to some guy or girl, actually to parents. They're explaining data, explaining about the girl or boy they are suggesting. So first of all, we need to extract data from the calls in order to map data to a necessary person in a database. Meaning that first of all, we need to understand what data we have in CRM and try to find the necessary data inside the call. And after that, when we mapped the person, we can extract other data and add it to the CRM itself. And based on this mixture of features, already run a machine learning. And of course, this all not 100% sure, we need a good feedback loop. So we present also predictions. For example, they want to predict who is the best match for a specific boy or girl. We 10 options and of course give quotes, the date of the call, who talked, so as much data as we can in order to give them kind of a reasoning. They approve this reasoning or make changes. This makes us a feedback loop, and we update the features, and rerun the machine learning. So this is the first example of how we used feature extraction. Let's go to something more specific to our domain. As I already mentioned, we collect a lot of data from the free web, open web, meaning posts, articles, social media sometimes. What we want to understand is if specific item will become viral. We want to understand it as soon as possible when the article just published. So what we do, we collect all the data, extract from that features. For social media post, it can be something else, and for the articles another. For example, language, country, tone, emotions, anything that can be extracted. We build an SQL database, run machine learning, predict what will be the popularity of the post in 3-5 days, let's say. That gives our clients a possibility to understand what they need to pay attention to more. And because we're on the Python conference today, let's see a few lines of code. So on the line 2, you can see that we bring a base field. We know that there is a list of the fields that will be important for almost everyone, like I already mentioned, gender of someone who wrote this article, post, language, country, maybe even education level and so on. Secondly, we add the custom fields because our clients in different domains, someone in politics, someone in cosmetics, the questions that they're interested in are different. And after that, we build a pandemic model. Of course, we log everything to LLM usage table because I need to understand who ate all my tokens. And after that, we ask LLM to give me a structured output and save it all together to JSON, and after that to working with it in the database. Specifically for emotions, this is kind of strange, and don't ask me why, but all of our clients define emotions a little bit different. So for that, we use a collection, the set of the kind of training posts and articles. We give our users this list and ask them to say what emotions they see there. And from this, let's say, training set, we defined what emotion is in their domain. And after that, we just do a vector search because we have this super long, super detailed definition of the emotions. And we just do the vector search. It's worked better for us. I know that actually LLM is super good with the sentiment things, but kind of it didn't work out of the box for our clients. So we made this strange move. And actually, in continuation to what we just mentioned, we can use those extracted features from the social media in order to merge data with internal data set of the client. And this gives us a lot of new data. For example, I have a CRM database of the people. I can now enrich it with the interests, for example. Means I try to cluster people in the small groups of social demographic levels, let's say, and find in the social media ideas that they mention, articles that they're reading or writing. And this gives me a lot of new features to enrich my data set, to after that run on top of this or ML, or just to create different reports. So it's also a nice way to mixture things together. We talked about that. And the second approach is model development and automation. I will go briefly through that. Here we talk about feature engineering. It's like giving a columns of the database to the model and try to ask LLM to help me to create a meaningful features. Second is hyperparameter tuning. Now I don't need to go through all of the database, through all of the parameters in randomly. I can ask LLM to give me kind of ideas, what hyperparameters should I start in this specific domain. And of course, to create a full pipeline, let's say also to build agents with a tool that knows to automatically engineer the features, tool that can tune hyperparameters, and maybe also a tool that can explain me results of the model. Third thing that we actually really focus in our company is explanation. Reasoning and explanation is very important because our customers are not very technical people. They need a lot of free text to understand the results. So first is explaining the machine learning and give recommendations. It's important for our clients to understand why a specific prediction wasn't good and what they can do with it. And we'll see soon the example how we can help with them with it to non-technical users. Grounding of ML results is also something interesting that we found out for ourselves is that actually I mentioned that we worked a lot in political sphere, so we predicted a lot of election results. And with election results, you can actually kind of verify yourself through the web search. There is a lot of different surveys that published. So when we run ML and create those nice reports, we can actually mix data, also present what was run, what was created from the data of the user, but also to kind of ground it with what we found in the free web, in the internet, and the social, to understand if we're aligned with the reality. And the third thing, what I mentioned before, is data validation. Our clients import databases. They don't really know to evaluate if it's ready to build machine learning. So this is the third use case. So let's see how we built our explanations, our reports that actually explain the machine learning to non-technical users. Well, firstly, we prepared a list of features. What actually what columns we have and what features our model generated. And after that, we do something very simple. We just give the model prompt that here I am, I want to develop the ML model, my target is what I want to predict, what I have in the column that I'm trying to predict. Given from my best knowledge what are the best set of columns, you of course can write here something, some prompt to Perplexity grounded with academic research to understand what are the best columns for your domain, but we have it in our database already. And after that, I say that here is a type of prediction model that I would use. We, for example, use for political domain random forest most of the time. And giving data and asking just to suggest me something. And it works surprisingly good because, first of all, it gives kind of a data scientist advice from nowhere. And really helps in the end to understand why the results were less good, giving the first touch of the data scientist view on this. So in the line 11, you can see how we interact with our agent. And after that, editing suggestions. And of course, there is a lot of error handling because LLM sometimes answers some not appropriate things. Let's see example of the verification with validation, with grounding, news grounding. How we do it? First of all, we have our machine learning results in the SQL database. On the other hand, we have everything that we're collecting from the open web, social medias, news, publications, everything stored in VectorDB. We see what we predicted. We save all the metadata of the models in the database also, so we know what we try to predict. We find the similar things in the VectorDB and give it all together, creating the report that actually explains ML results from the side of kind of advisor, expert of the domain, because if you have all the data from the open web, you understand the domain and you can actually kind of understand if the machine learning gave you something logical and even reason it with the real events. And also, like taking one step before that, to understand if my data is ready to run machine learning, also we have this nice prompt. We give to the model examples of the values in the columns and ask basically if those statistics, this number of columns, this number of rows that is not null values, so this number of categorical, numerical, and so on. If there's something that I can use for my model, yes or no, with the reasoning, and this also gives us a very nice touch of your own data scientist in the system. So here you can see very few examples. What we do, we take the table that we're working with, because sometimes our client have a lot of different CRM system connected, taking all the columns into consideration, except of course the model results columns themselves. We generate query to select few first rows, random rows, execute it all together, and generate the prompt that you just saw, put it together, and actually receive a nice written, human-readable report. And of course, there is a lot of domain-specific applications that you can read about them specifically, for example, for legal domain. We had a very interesting research. There is a lot of problems with the context window, but machine learning solves it. A lot of different things that specifically in the domain, in specific domain, there is a lot of use cases of mixing ML and LLMs. So thank you for your attention. This was my first conference time, so thank you for coming. It's not taken for granted. And if you have any questions or want to connect, please feel free. This is a barcode to my LinkedIn page. Thank you.